Alright, so with this number 2 from chapter 3, section 2, it's asking us to find the maximum and minimum. And remember, we had to play around a lot with Desmos to help us find the answer. And so let's just take the derivative of our function, which is a pretty easy one to find, just using a power rule. And so now this is what we want to set equal to 0. So this is what is going to help us find the critical value. So to find a critical value, you take the first derivative, set equal to 0. So I could factor out a 4x squared on both of these, and I'm left with x minus 12. So that means each piece is equal to 0. So that happens when x is 0, and when x minus 12 equals 0, so at 12. So at 0 on the graph we saw there weren't any, there wasn't a relative minimum or maximum. So at this place, it is a critical point, but there are no min or max occur at this critical point. At 12, we did find that value that was way down low. But this way, we could actually find out what that value is by just plugging it in to our original function. So it was x to the 4th minus 16 x cubed. And so if we plug that in, we're going to get the value that they got, which should be like negative 6,912. Now, then there's that word problem. That word problem was pretty intense. Looking at it, it talked about the quantity demanded at x for a product is inversely proportional. So let's go to a new page. When we're looking at that, so the quantity demanded is x, it's inversely proportional, so that's k over, and it said the price cubed. They also gave me a cost equation. That was a nice linear equation. It was 120 plus 4 times the number of items sold. But then it wants to figure out the price when we maximize profit. So that's something totally different. You know, profit is revenue minus cost. So here's my cost equation, so I'm good there, but I need a revenue equation. The revenue, the way you find revenue is you take your price and you multiply it by the number of items you sell. That's your revenue. So to do that, we have to first finish this equation. We need to solve for k. They gave us information to find what k is. They said when the price is $10 per unit, the quantity demanded is 125. So first let's find out what k is real quick. So the quantity demanded was 125 when the price was 10. So we just get 1,000 times 125, so k is 125,000. So now we can look at this equation as this. But for revenue, I need price times quantity. So I need to solve this thing for P. So a little bit of algebra, and I get this, and then P will just be the cube root of all this. So almost to the point where I can write my profit equation, because it's revenue, which is my price times quantity. So I have that equation. So that's my price times quantity x, subtracting my cost equation that they gave us, 120 plus 4x. So this is going to find the x that maximizes profit. So this is what we'd want to put into Desmos and find where that maximum occurs, because we're maximizing profit. But this gives me the x value. So whatever x value we get here, we need to take that and plug it back in to this equation. Or maybe not this equation, this would be the best equation to plug it into, because we want to figure out our price that maximizes our profit. So whatever value you get, either, I'm going to say, if it's a word problem, graph that thing and find your min and max. Find where our maximum occurs for this equation, And that x value that we find, we're going to plug in right there. And then we'll have an equation to figure out our price.